Then we do this integral by two methods, and this is not a really difficult one, but it's a good example for the students taking basic calculus course. It's really nice to practice the basic techniques of integration. Okay, now this integral I can do 1 plus x squared. Here I can x plus e to x minus e to the x and the dx. Now the reason of adding and subtracting e to x, I want to simplify the fraction. So this is equal to e to x is common, then x plus 1. Right, that is 1 plus x squared and minus e to the x, dx. And therefore this can be simplified as e to the x 1 plus x dx, right? And minus e to the x. Now 1 of x squared, I can write this 1 over 1x plus. That would be 1 over 1 plus x squared, but negative. I change the negative to positive, so that correct the negative sign. Now then, this is equal to e to x dx 1 plus x plus. Now this can be done by parts, right? So this is u, this is dv. So this uv minus v du. V is 1 plus x, du is e to the x dx. See, that one cancels with this one, no? So the result is e to the x 1 plus x plus c. See, that is the result. Okay, this is method 1. Now method 2. I copy this one is x e to the x 1 plus x squared. Let me change the pen. Okay. 1 plus x squared, I can write the derivative of 1 plus x. So this derivative with respect to x is a negative 1 over 1 plus x squared, right? So I change it to the negative outside and left to this. Okay, that's easy. Then I can use it by parts. This is u, this is dv. So it becomes 1 plus x and x e to the x negative, negative. The uv, this is u, this is v, minus v du. V is this, du is this, is e to the x, right, plus x to the e to the x. That is the derivative of this with respect to x, right, then a dx. then this is equal to negative also. Negative x e to the x 1 plus x plus negative and plus. Now this is this becomes e to the x, right? 1 plus x dx. So after cancel this one, it becomes this 1 plus x plus integral e to the x. And this one is equal to negative x e to the x 1 plus x plus e to the x, right? Plus c. Now this one is equal to, I can simplify by using common denominator, is negative x e to the x. This will be plus 1 plus x times e to the x plus c. Then this time this one cancel that one, is equal to e to the x 1 plus x plus c. See, that is the same answer as the first method. Now, if you try in the first place, if I try this d e to the x, you will find that this is equal to e to the x 1 plus x dx. Okay, now I'm not going into detail. You tried it. This is this. Therefore, my integral 1 plus x squared dx can be written as d e to the x 1 plus x. Therefore, right away, you get the result e to the x 1 plus x plus c. You see, that could be considered a method. If you're really very, very nice for derivatives, at the first place, you can write this integral as this, then the result. Okay, thank you for your watching.